Welcome back. In this video, we'll be talking about manipulating expressions involving pi notation. Just like in the previous video, we have expressions where we're taking the product of factors that come from two different other products. In such a situation, we can write the product from k equals 0 up to n of a sub k, b sub k, as the product of two individual products, product from k goes from 0 up to n of a sub k, times the product for k goes from 0 to n of b sub k. Similarly, if we have the product of a quotient of a sub k and b sub k, then we can write this as the quotient of the individual product of a sub k divided by the individual product of b sub k. In pi notation, there's also a manipulation that involves multiple copies of a sub k. We can think of this as the product of m copies of a sub k. We can apply our product manipulation from above and see that this becomes the product of m individual copies of this same thing, the product from k equals 0 up to n of a sub k. This leads us to a word of caution, though. If you remember, on the previous video, we had an expression that involved the summation of k goes from 0 up to n of c a sub k. Now, for products, the right way to think about this is that there's a copy of c in each of the factors for k goes from 0 up to n. So there's n plus 1 factors of c that are all multiplied by this individual product from k equals 0 to n of a sub k. And just as with summation notation, if we have multiple products whose indices are compatible, then the product of those individual products can be assembled to form one product where the indices start off at p and go all the way to r. Again, let's do some examples. Let's consider this product, the product where I goes from 1 up to n of 2 over I to the 5th. We see this as a quotient, and so we can write this as the product where I goes from 1 up to n of 2 divided by the product as I goes from 1 up to n of I to the 5th. Now, because the denominator is a product of something to a power, we can write this as the product I goes from 1 up to n of 2 over this individual product I goes from 1 up to n of I to the 5th power. And now we look at this product. This is a product of constants, and so this is 2 to the number of terms that there are. Here our index starts at 1 and goes up to n, so there are n factors, so we get 2 to the n. And in the denominator, this product is 1 times 2 times dot 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 up to n, which is n factorial. So n factorial to the 5th. This product is equal to 2 to the n over n factorial to the 5th power. Here's another example. We see this product where k goes from 29 up to 55. We can split apart this product into two different products. The product where k goes from 29 to 55 of 6 times the product where k goes from 29 up to 55 of k. Let's calculate each of these factors independently. So this first factor is a product of a constant for some number of factors. And so the number of copies of 6 that we have is the numbers from 29 up to 55, which we can calculate as 55 minus 29 plus 1, which is 27. And so this product is 6 to the 27th power. Now let's do the other product. This other product looks a lot like the formula we used above, where if we had the index starting at 1 and going up to 55 of k, this product would be 55 factorial. And so we need to use the index manipulation for products and see that this product, where k goes from 29 up to 55, is the same as the product where k goes from 1 up to 55 divided by the product where k goes from 1 up to 28 of k. We only go up to 28 because we want the 29 index to still be in this product. So the product where the index goes from 29 to 55 is the same as the product where the index goes from 1 to 55 divided by the product where the index goes from 1 to 28. That, in turn, is 28 factorial, and so this second factor of the product is 55 factorial over 28 factorial. And so this product evaluates to 6 to the 27th times 55 factorial divided by 28 factorial. That's it for now. See you soon.